All right, now we're going to look at finding total momentum. Now, to find total momentum of a system, the system is going to include more than one object or more than one person, vehicle, whatever it is. You find their individual momentums and then you add them together. So you have to find the momentum of each individual component of the system and then add all the components' momentums together. For example, if I gave you that, say we had two football players, a running back and a linebacker, running at each other. And the running back had a mass of 60 kilograms, the linebacker had a mass of 75 kilograms. The running back is running upfield at 3 meters per second, linebacker is running downfield at 2 meters per second. Now, if you notice I made the two negative. If they're running at each other, one's running in a positive direction, one's running in a negative direction. Doesn't matter which you assign to be positive or negative. If I assign the running back to be positive, then the linebacker is going in a negative direction. It could be vice versa, doesn't matter. But once you assign whichever direction to be negative, it's negative throughout the problem. So if I ask for the total momentum of that system, that is whenever these two football players collide, well, first we're going to find the momentum of the running back. You just take his mass times his velocity, or 60 kilograms times 3 meters per second, you get 180 kilograms meters per second. If we look for the linebacker, we take his 75 kilogram mass times his negative 2 meter per second velocity, you end up with negative 150 kilograms meters per second. And total simply means to add. So we're taking 180 plus a negative 150, we get a total momentum of 30 kilograms meters per second. Now, that's all fine and dandy, but let's look at it, take it a couple steps further. Whenever the linebacker is tackling the running back, they basically become one unit. So we actually have a new mass, that is total mass. Just take their two individual masses and add them together. So you have 60 plus 75 gives 135 kilograms. Now that is their total mass rather. We have their total momentum, we have their total mass. What if I asked you how fast they're moving once the linebacker starts to tackle the running back, and what direction are they moving in? Well, we have mass and momentum, we're looking for velocity. The original formula for momentum is P equals mv. If we rearrange that for velocity, velocity would be momentum divided by mass. So in this case, we have momentum of 30 kilograms meters per second divided by the total mass of 135 kilograms. So if you simply do the division, you have 30 divided by the 135, you get 0.22 repeated. So the velocity here would be 0.22 meters per second, because kilograms cancel out. The only unit left is the meters per second. So that tells us how fast they're moving. In other words, one's pushing the other one back, but in which direction are they moving? Well, since this is positive, they're moving in a positive direction. Who had the positive velocity? The running back or the linebacker? Notice the linebacker had the negative 2, the running back had the positive 3. So in what direction are they moving? They're moving in the direction of the running back. If we said the running back was running upfield, due north, whatever it is, they're running in the direction of the running back. So not only do we calculate the total momentum of the system, we took it another step further, and after the collision, we found out how fast one was pushing the other one back. In the next video, we're going to look at something called the conservation of momentum.